Hi there. The other day I was talking to this guy on my amateur radio, 2-meter radio, and he said your audio's a bit low. Well, I'm not really in the habit of shouting into microphones, but you know, I tried turning the gain up, the mic gain on the radio, and he said it didn't make a lot of difference. He said to me, he was using the same radio as me, you need to buy an ICOM SM20 or SM30, which is a bass microphone with an amplifier in it. I thought, okay, fine, I'll have a look at that price, see how much they cost. And of course, it was enormously expensive. Well, I thought it was expensive for what it was. It's 150 roughly, I think it was. 150 quid. I thought, no way am I spending that on a bloody microphone, because I know what's in it. They always use a standard electret condenser mic capsule, which is probably about 50p's worth, and the capsules themselves are pretty good. Even basic ones, you can get them out of scrap phones, whatever, and they've got a good frequency response, and they're small, whatever. So I thought, no, I'll have a go at building a bass microphone. Not going to spend 150 quid if I can make one. So I had a look around in all my junk, and I came across this. Now this is what was originally part of a headset with a boom mic on it, which that's the boom bit, comes out in front of your face, obviously, off the earpiece. And I picked this headset up in, I think it was Poundland, about 15 years ago. I bought two of them. I think they were £1 each, obviously Poundland. And the idea behind that was, this old lady I knew had this cordless phone, and she wanted to be able to walk around the house with the phone in her pocket, both hands free, and talk on the headset. And I think it worked fairly well from what I remember. Anyway, I had the other one still here, so I ripped off the boom bit, microphone bit, threw the headphone bit away, and this is the result. And it's okay, it could be a bit longer, but I think it'd be alright. I was going to mount it in the top of a die-cast box, and I also found this bit here, which is not part of the original headset. I think it's a strain relief for a mains cable, and it went through a chassis, obviously, with a bolt to tighten it up, which is really handy for mounting in the top of a die-cast box. Anyway, these condenser microphones, electret condenser mics, of course, have got a transistor in the actual capsule, which amplifies or impedance matches the very high impedance, and they need about 1.5 volts to bias them, roughly. So I've got it wired up on the bench at the moment, and I'm actually using an 8-volt supply, because that'll be what I'll be using off the transceiver, because it's got 8 volts available at the mic socket, which is quite handy. So as I said, I got it wired up to the scope. If I go over to the scope, try and you have to turn the light off, or it might be alright. Anyway, if I whistle into it, I'm getting over 100 millivolts, which is absolutely fine. So yeah, I mean, yeah, so what I'm going to do is I'm going to use this simple little microphone amplifier circuit. It uses a BC547 transistor, but I'll be using a surface mount equivalent to that, because I like using surface mount. You don't have to drill holes through the PCB, and everything's so small and compact. And I've had to modify the circuit slightly, because they've got 210 microfarads in series electrolytics on the input from the electric mic, and I haven't got any of that size in surface mount, so I'm just going to use two 1 microfarads in parallel. I think it'll be fine. And what else we got here? We got biasing for the electric mic, 4.7k, and that's biasing for the transistor. And I'm going to use a 1k in the collector, and I'm going to use a 1k pot there, so I can tap off the audio and vary the output, and then that'll be taken through another 2 microfarads, two 1 microfarads in parallel. And yeah, and up here we've got 8-volt supply coming in there. Put it through 100 ohms, and then just decouple it, just to keep any noise off the supply to the transistor amplifier. And what else we got to say? This is the connection diagram for the transceiver. It's got 8 pins on it. I don't need the frequency up-down connection, I'm not going to bother with any of that. Mic input, that's okay. Now I thought I wouldn't have enough cores in my cable which I'm going to use, because according to this you've got a separate ground for your PTT line. In other words, you connect that to that and it goes into transmit. Then you've got another ground for your microphone ground, 2 separate grounds. But having measured the connections on the transceiver, they're all, both grounds are connected together. They're less than an ohm to earth. So I think I can get away with just 4 wires. There'll be the 8-volt supply for the amplifier, mic signal back from the amplifier, common ground for that, and a PTT line. And I'm going to use the cable that was on the use this bit of cable here which was actually on the headset, and I'll use the center conductor, screened center conductor for the audio, and common ground for PTT and audio. And on the other one it's got another screen cable, and I'll have to use the center conductor for the plus 8 volts, and the screen of that one will have to be PTT line. So that should be okay. And just go over to the actual circuit board I'm planning to make. Need a bit more light maybe, it's a bit shiny, this circuit board. And this is all there is to it basically. You've got your input coupling capacitors, 2 1 microfarads in parallel, and the tiny little surface mount transistor, which is a BC849. It's basically a BC109 in a surface mount package. And the output coupling capacitors, obviously the pot isn't on here because that'll be mounted in the box, and I haven't got that yet, I've ordered that. Then you've got your biasing for the transistor, 220k, and that's a 4.7k to bias the electric condenser. That's my decoupling, that's the last of my decoupling capacitors, high value capacitors in surface mount. That's 10 microfarad, and above that is 100 ohms just to help with the decoupling of the supply. I probably won't need this circuit board to be this big, but I'll work it all out when I draw the etch resistant on. And yeah, I'll go on to the idea for the PTT now. Okay, so I wanted the PTT, that button that felt okay and nice to use. So I'm going to use this micro switch, a bit big, but it's probably rated about 10 amps, but who cares. And it's got a nice clicky feel to it. nice clicky on and off feel. So I thought, well, what am I going to use for a button? So I found this little rubbery button, which I think came off an old multimeter, and that will sit on top of there and cut a hole in the die cast box, top of the die cast box, and that'll go up and down and click away nicely. In fact, I've got a old lid of a die cast box here, so that will go through there. Obviously I'll cut the hole to the exact dimensions of the button, and then you have the PTT underneath there, the micro switch, and press it and it goes up and down, whatever. But I'm still, I've ordered the parts yesterday, a die cast box, which is about £5, 1K log pot, and also a 8-pin mic plug to go into the transceiver. And at the end of the day, if it all works, it will have cost me the grand total of about £11, I think. It's better than paying over 100 for an Icon microphone. So yeah, what else can I say about this? Yeah, you've got 8 volts coming off the transceiver mic socket, as I said, and they do say in the manual, this 8 volt supply, you've got a maximum of 10 milliamps available. Well, in theory, in this circuit, you got 1K across here. If this was a completely turned on and had no volts drop across it, you'd only be drawing 8 milliamps down that resistor. So that should be okay in theory. But I think what I'll do next is I shall draw out the circuit with etch resistant and get that etched, and then just wait for the other parts to come. So I'll go ahead and do that bit now. Okay, here's the finished board in front of you, all etched and ready for soldering. And I'm going to try and solder the components on the cameras, but that'll probably end up as being a disaster. But anyway, I'll have a go. I think the first thing I'll put in is the transistor. I put a blob of solder on the board. I should have this board stuck down because it moves. But anyway, then I can get hold of the transistor. If I can get one of its legs anchored, should be easy after that. Right, that's got the collector on. Do the base and the emitter. Afraid the lighting isn't great. Anyway, that's the emitter. That's the base. Just try a bit more. Might be better lighting. Anyway, just do that collector again. Fine. And what's next? I think next is bias for the transistor, which is 220k, which I've just dropped. And it's jumping around the workshop bench. I've already got some solder on the collector, so I can just get it on one end. Okay, now the track that goes to the base, and just touch up the other end. Fine. If I zoomed in a bit, maybe that would be better. I don't know. I keep knocking the bloody camera as well. Anyway, what's next? Do the input coupling capacitors. One of them stuck on. I'll do the other end of it so it doesn't escape. Right, now the other one. Not easy. It's not easy soldering and making sure everything's in view when I'm doing it. Okay, let's go that one on, and the other end of it. Yeah, that's pretty good. What next? Bias resistor for the condenser mic goes up here. And the other end is easy once you've got the first end on. Next, 100 ohms. Where's my 100 ohms gone? I had it not long ago. I think the components are escaping. There's a 1 micro. I had it, there it is, it's gone up there and it's turned itself upside down and it's blended in with the paper, so I couldn't catch it. So I'll stick a bit of blob of solder on that bit. 100 ohms, part of the coupling. I just don't know how people do this on camera, even with a microscope. Anyway, that's the 100 ohms in. Next, I'll put in the coupling 10 micro, which I'll get it all in shot again because it keeps moving. I think I'll put some solder on the bottom of the legs, one of the legs. Right, so I've got that on, and positive is at the top. Right, that's just enough. I think it needs to move a bit. Right, got that end on, tacked in place. The other bit will be fairly easy underneath the capacitor, and just finish off on the bit more solder on the top end. No, I've gone and put it in the wrong way around, onto the wrong track. That track is P2T line, and I've gone and stuck it on there. I'm going to have to pause for a second while I remedy this disaster. Okay, got that off with hot air. I hope I haven't damaged it too much. Get a bit of solder on the positive end, and the other end goes down to earth. Fine, a bit more on the top. Get rid of that mess there. That's good, got rid of all that crap. Now 2 more components. It's the output coupling, 2 microfarads. And the other end, I think, and the other capacitor. If this capacitance isn't enough, I should just stick more on top. It's the good thing about surface mount devices. You can stack them if they're square like these are. Okay, so got that in. Other end. Finish off this end a bit. That's all the components in. What I'm going to do is I'm going to, because I haven't got the pot yet, I'm going to use a 1K fixed resistor and then just check on the scope to see if I'm getting plenty of audio. So the 1K goes between this positive pad and the collector transistor, and it also needs to go to that output pad that's connected to the capacitors. So I'll just do that and solder that one on there, and this one goes to the positive supply. Well, there you are, it's finished. Well, for the test, for the testing anyway. It'll have to be obviously redone when I get all the other bits, but it's not the neatest of boards I've ever done, but it's really not a good idea trying to do it through the viewfinder of the camera or the screen of the camera. So I think the next thing to do is I'll wire it all up and see if it actually works. I can actually wire in the microphone, and brown is positive on the microphone. I keep knocking the bloody camera, which is irritating. So positive, yeah, that's positive there. And negative earth down to there, and I need some power wires. Let's see if I can find any power wires. Right, found a nice piece of red wire for the plus 8 volt. As you can see, I've labelled this track 8 volt. Well, you might be able to see, I don't know. I think I'll have to zoom again. That's 8 volt there. Nice bit of red wire for that. And blue wire, that'll do. For the negative. Fine, got that on. Right, let me just rearrange the bench a bit and get the scope in the right position and turn the power supply on. So, okay, so all wired up now as best I can do it, and just about to turn the power supply on. Okay, it's always drawing 3 milliamps, that's all. If you want to see the power supply. 8 volts, 3 milliamps, that's bugger all, isn't it? Bugger all. Now I shall go over to the scope. And I do my same whistle test as I did before, old grey whistle test. Can't bloody whistle today. What am I on? 200 millivolts of division. Massive signal. Let's turn it down a bit. 500 millivolts. Well, that's a hell of a lot more without the amplifier. Hell of a lot more audio there without the amplifier. More than enough to sound extremely distorted on a radio. So I'm going to now do nothing at all because I haven't got the rest of the parts yet. Microphone plug came today. Still waiting for the pots and the what else am I waiting for? I've forgotten. Die-cast box, that's right. Die-cast box. And then there'll be a lot of drilling and messing around with all that, trying to get that PT switch installed properly. And then what else is this to do? And I might even paint it. I've got some black paint for the box, but I haven't got any primer, so I don't know what I'll do about that. I don't want to go out and buy primer. I might just rough up the box a bit with emery paper and then paint it. Might be alright. Anyway, wait for the next session to see how that goes. Okay, back on this mic amplifier project, and the pot turned up today. Still haven't got the die-cast box. It did say UK seller, but I am suspicious about that because he had a Chinese name, but we shall see. Anyway, the pot turned up and I ordered a log pot, and of course they sent me a linear. I don't think these people have any idea of the difference, but you know, it did come with a nice gold aluminium knob, so I suppose that's some compensation, and I'll just use it anyway. So if we go over to the scope, and as you can see it varies quite nicely, and up to 1 volt RMS I've got there, goes a bit higher than that, and I'm inputting 10 millivolts at the moment to get 1 volt output at 1 kilohertz. Now I wanted to do a frequency response test on this, so I've got it also wired up to my HP audio analyzer. I'll just take the camera up to that. Right, as you can probably see when I get the camera right, it's reading 1 kilohertz, and same as the scope was reading, about 1 volt. So if I put this into ratio mode as 100% and I go into log, so I'm now measuring the difference in dB as I vary the frequency, and as you can see at the moment it's 0, so that's the reference. So if I go down in frequency, right, I'm going down now to 900, the same, 800, that's 700, anyway, 600, 500, 400, it's jumping, but never mind. Down to 300, so we got right down at 300, which you get 0.3 dB loss, so it's not too bad, it's reasonably flat. 200, 0.6 dB, 100 is -2, that's okay. I mean, really you're only looking for 300 to 3K or 3.5K maybe on a communications transceiver. So I'll go up the other way in frequency. It's back to 1K, 2K, 3K, flat still, 4K, 5K or whatever, still flat, and it's completely flat, which is fine over the range I want to use it on. So I'm quite impressed with that. Those input and output coupling capacitors, it appears, do not need to be altered to higher value ones. Anyway, the other thing I was been working on while I'm waiting for the bloody box to come, I was going to use this micro switch. Well, I don't really like it, it's too big, be hard to mount it, I have to make some metal brackets up, didn't want to bother with any of that. So I found this little one here, and it's much smaller, meter, and I've just knocked a hole up in this box to the right size for the button and screwed it in. I had to tap these holes to 3mm, and I'm spacing it with some nuts which have had the centres drilled out to 3mm, so they act as spacers, and it seems quite okay. It's quite critical. I had to bend the bracket slightly to get it in the right position, but it does work quite well, if you can hear it clicking. And as I said, it's much smaller and neater. I don't want an enormous great switch in the box, so there we are. That's as far as I can go really for the time being, until the bloody box turns up. The estimated delivery now is 3rd of June according to eBay, but I often find that's the latest it's likely to come. I've had stuff come a lot quicker than the estimated delivery time. So not much more I can do for the time being. I might add a couple of 100 puff capacitors on the input and the output down to earth, just to filter any RF that might try and get in, because RF will do its best to get in if possible. Anyway, that's it for now. Okay, back on this project, which is taking too long as usual. But anyway, got the box through today. Took 10 days to come, supposedly from Manchester. Now, it's pretty obvious from the packaging it came from China, not Manchester. But anyway, 10 days is not too bad from China. But it's annoying when they say it's coming from Manchester. But eBay should crack down on that sort of thing. Anyway, this is the bottom of the box, all drilled. Hole in the end for the grommet where the cable comes in. I've mounted the circuit board on a big lump of brass to give it some weight, so so it doesn't sort of slide around everywhere. That was an old block of brass I had. I used to use it as a heatsink for a RF amplifier module which I blew up many years ago, but nothing goes to waste here. It went back in my scrap metal drawer and it'll be very useful here. And sticky feet to go on the bottom when I've painted it. So the top of the box is here, and I had to drill with a switch, micro switch, 2 holes for that, and drill and file for the button, and you only got one chance to do this, otherwise you've ruined it and you have to buy a new box. But I've done this so many times, I think I'm fairly good at it now, and it clicks away quite nicely. I might cut it a bit shorter actually, but I'm not sure yet. This rubbery button sticks up a bit high. Anyway, boom mic, that fits in fine, and gain control pot. I'll probably space it a bit because it sticks up, the knob sticks up a bit too high, it looks a bit untidy like that. So what have I got to do with it now? I've got to take it all apart again, but it's not too bad, and get it, sand it down a bit. Hopefully the paint will stick a bit better if I sand it, and then give it a few coats of paint. Use spray paint, black spray paint. I'll get a few coats done this afternoon maybe, we'll see. Anyway, I'll get on with doing that next. So here I sit watching paint dry, and it really is tedious, but I found a novel way to speed up the process. I've got it sitting on my amplifier dummy load, which I'm putting 18 volts at 4.4 amps into, and that's producing about 70 odd watts, and that's quite successful I think. And temperature is around about 50 odd degrees, so certainly will speed things up. Maybe a couple more coats I'll have to put on it, and then I can finish the bloody thing off. It's like all of my projects, I just want to finish it. Okay, here it is, the finished product, if you want to call it that. Paint work turned out quite nice. Yeah, of course it might all fall off, being not, as I didn't prime it, but who knows. Anyway, I'm not too bothered about what it looks like. It's how things work that bother me more than how they look. I think the label I printed out for the gain control didn't come out that good. You've only got to touch it and the ink seems to come off, but as I said, I'm not too worried about that. Have a quick look inside, and there's the inside of it all fits in very nicely. Nice little circuit board in the middle, and plenty of room for everything to go in there. So I just screw it down and maybe do a quick demonstration of it if I can. It won't be easy because I'll get loads of feedback if I try and transmit and receive on another receiver, but I'll have a go anyway. I can sort of try and compare it to the hand microphone that you get with the radio. Even thought about putting one of those little amplifiers inside the hand microphone, but I don't really want to drill holes in it and whatever. So there you are. I'll just do a quick demo. Okay, I want to try and demonstrate the difference between the supplied microphone and the one I've just built, and it's not going to be a very good demonstration because having this receiver, which is an ICOM 8500, so close to the microphone, you just get loads of feedback. Anyway, I'm going to move this over to the near the speaker, and I'll first of all put the supplied microphone on. Audio test, testing audio on the standard microphone. Okay. Okay, this is the new one I've made, and as you can see, loads of feedback. Well, but there's loads more output. That's the main thing. Loads more output from this microphone. Yeah. So, not a very good test really. You'd have to be at the other end of a radio. But I'll try it out anyway and see what people think of it. Okay, that's the end of this video. Not a very good ending, but there we go. Bye for now.